So if you guys have already played with the drag and drop, then you kind of know the answers already lah to all this, right? So any questions or not, I didn't write the answer here, but any questions about the interpretation of the graphs? Like any of the answers you're like, why the answer is like that? If you didn't play, then you don't know what to ask, lor. Takes you like less than 5 minutes to play, okay? Any questions? No? If not, I don't want to spend time on something you already know. I will move on, okay? So the interpretation is important because when you do experiments for physics, you need to draw graphs, right? And when you draw graphs, you also need to know how to interpret. That's why this is a little bit important, the basic. If no questions, let's go on. Can you guys flip to page 12? Additional interpretations you need to be aware of is, I think you learned this before already. You know how to calculate gradient? You all know how to calculate gradient? What's the formula for gradient? Y equals mx plus c is the general equation. Yeah, correct. Gradient is y2 minus y1 over x2 minus x1. So in physics, right, gradient is important in terms of interpreting graphs, because when we learn more now, I explain to you like this so you will understand. But generally, because the experiments that you need to conduct in physics, the values that you obtain is not just reserved to whatever you draw on a y and x axis. Calculating the gradient also will give you an additional measurement, which will help you understand the concept better. So if you don't know what I'm talking about, you never mind. We will do an experiment, then you'll see what I mean. Okay, so that's in terms of gradient. What about area under the graph? Have you learned before this concept? Okay. In maths, never learn area. Oh, okay. Area under the graph means this. If you have a graph like this, what happens is, normally, right, let's say they'll give you the value, like, let's say x between 0 and whatever, let's say x up to here, let's say 10. So when you want to count area under the graph, means from the graph, you imagine the two coordinates from the graph, these 2 points, x is 10 here. So from 0 to 10, from the x-axis up to the graph, can you see the shape of the graph? Shape of the area, I mean? Yeah. What shape is this? How do you calculate area of triangle? Half base height, correct. So for this situation, you would count half base height. If your graph is not a triangle, let me see, did I prepare this? If your graph was not a triangle, let's say if your graph was like this, say if your graph was straight line, and then here, let's say so let's say, for example, the question didn't ask from 0 to here, let's say up to this value, whatever it is. Oh my god, imagine it's straight. Let's say from here to here, let's say 2 to 20 . So what happens is, if you have to count the area, you need to count the area of the graph like this. That means from the graph down to the x-axis. So why we call it area under the graph is because it's under the graph down to the x-axis. So when you see this, can you see the shape of the graph here? Weird shape, right? Do you know how to count area of this kind of shape? Split, separate into what? You can separate a triangle, yes. So that means you have triangle, plus rectangle, then you count the areas like that. Yeah. Okay, so that's how you calculate the area under the graph. Normally the question must give you where, like what's the starting and what's the ending values, then you count the area under that. Okay, so that's how you calculate area under the triangle, area under the graph. So when to use this, the question will give you. It depends on the graph as well. So I won't explain much about this. I'll wait until the future topics where this comes up, then I explain. Okay. Sorry, I'm just gonna backtrack a bit to the gradient. By the way, right, when you calculate gradient for the graphs, besides calculating, you also need to show the gradient triangle on the graph. Okay, what I mean by gradient triangle is this. You know x1, y1, x2, y2, right? So let's say if we take this point as x1, y1, and let's say we take this point as x2, y2. When you want to show gradient calculation in physics, you must show gradient triangle. Now, what is this gradient triangle? A gradient triangle means this. You draw from this point to this point. You got the line here already, right? You drop this down, dotted line, must be dotted, dotted line, drop, and here also dotted line. Cannot see because got the x-axis, but never mind, you just draw, okay? This, that means from here to here, you already got the hypotenuse, make the right angle triangle. So you must show gradient triangle when you are calculating gradient in physics. The reason for this is because this shows the examiner you know how to calculate gradient. Because you see, right, a lot of people don't realize, right, what is actually a gradient calculation? Gradient is actually the difference in y over difference x. Because you're counting y2 minus y1, so y2 minus y1, if you look at it, it's actually y2, y1. This is your top one. And then x2 minus x1 is what? x2, here's also x2, and that's x1, right? Can you see? This is actually x2 minus x1, which is the bottom part. So this is actually, gradient triangle is actually showing you the steepness of the graph. You know, gradient is the steepness of the graph. The steeper the graph, that means the higher the gradient. So you see, right? Wait, let me. So you see, right? In terms of the gradient, if let's say, right, you have two graphs. Let's say I draw another graph, right, side by side. Here, let's say this one is steeper graph. Why we like to draw gradient triangle in physics is because this allows us to immediately compare the gradient. So you can see how for this graph A, this y2 minus y1 and this x2 minus x1, you can see, wow, the y2 minus y1 over x2 minus x1 quite equal like that. Then you compare to graph B, okay, this y2 minus y1 compared to this x2 minus x1, see what? x2 minus x1 so short. So y2 minus y1 over x2 minus x1 for B, x2 minus x1, the difference in x here is so much smaller. That's why B has a higher gradient. So that's why we need to draw gradient triangle. Okay. Anyway, this is just the y. If you don't remember the y, let's say later, never mind, it's okay. Just need to know, must do. So don't worry, I will go through with you how to draw the gradient triangle when the time comes. Okay. Last two bits is the interpolation and extrapolation. Do you know what they mean? Have you learned this before? Interpolation and extrapolation? Okay. To interpolate, the book doesn't explain. Interpolate means, right, if you have a bunch of coordinates scattered, Actually, right, I think extrapolation, what about extrapolation? Extrapolation easier. Extrapolation means this. To extrapolate means to extend the line. Where's the eraser? So for example, right, if you have a line like this, hanging in the middle like that, I'm sure you did before in exam. Like let's say they ask you, okay, based on this graph, right, what's the y-intercept? Correct? Then you're like, hey, how to get y-intercept? What do you do? Extend the line log, correct? You imagine this is your original graph. The yellow line is the pencil. Your pencil, you extend until here, correct? Hey, correct or not? You all learned this before or not? Okay, thank you. So when you do this extension is actually extrapolation. To extrapolate data means you have a group of data and then someone asks you, okay, based on your research or your experiment, can you predict the value that's outside your range? So you're like, huh, outside the range? But I didn't study this one. But if you drew a graph and you can find this relationship between y and x, if this was your experiment range up to from here to here, but you know, got pattern or I draw the pattern, got straight line or. So if someone asks you, what is the value, predict the value outside your range, you can still predict because the relationship is this one, straight line. So what you do is you extend the line, you can predict the value that is outside your range of data. And this extension can go both ways, can go backwards, can also go forwards. So extrapolate means to extend your data outside its range to be able to predict values outside of your experiment results. Does that make sense? Okay, good. So when you understand extrapolate, interpolate, you've been doing this all this while, you didn't know it was called extrapolation. Sure, the expression is drawn as a dotted line, right? In this case, actually, no, you can draw as a straight line, as a solid line. Because, okay, when do you use dotted and when to use solid? I know a lot of students are very confused about this. Let me explain. So if you have an actual graph, must be solid line. Solid line means no dotted. Now, if you extrapolate the line, you extend the line, is the line considered still part of the graph or not? What do you think? Yes. Yes, no. Actually, right, if you extrapolate and you extend outside, it's still considered part of the graph because it is still fulfilling the results of the experiment you conducted. So actually, even though you feel weird, but actually, right, an extrapolation is still part of your graph. So you actually still draw it solid because it is part of the graph. Now, when to draw dotted lines? Dotted lines are drawn when they are guidelines or they are imaginary lines. Example, if you're going to look up a value, question asks, when x equals 2, how much is y? Then you're like, let's say this is 1, 2, then you are looking up. When you are looking up values, this line is not part of the graph, then you draw dotted lines because it's your guideline. You are using this line to help you find the value of y. Then you use dotted lines. Same thing with gradient. That's why gradient triangle, you notice I draw dotted? Because it's not part of the graph, It's a guide. It's a guide for us to calculate the gradient. That's why dotted line. You see the area? Area also is also dotted because we use the dotted line to help us find, this one x correct up to this point, right? Find the y. That's your guideline. That's why you draw dotted. Does that make sense? Okay. So coming back to interpolation. So interpolation, you've been doing this all this while. Like I said, you just didn't know it's called interpolation. Interpolation is this. Have you drawn best fit lines before? Yes, right? So what happens is, to interpolate means now you have a set of data, right? Extrapolate means you go outside your range of data. So interpolate means you go inside the range of your data. Now, let's say, right, you did your experiment, you already found these sets of values, right? 1, 2, 3, 4, 5. But then someone asks you, oh, let's say for example, this is, let's say 1, 2, 3, and then 4. Last one is 5. Okay, I know it's out of range, but never mind. Because it's nearly time, I'm just going to go this quite fast. Let's say 1, 2, 3, 4, 5. Then someone asks you, can you look up when x equals 1.5? How much is the value of y? And then you're like, oh yeah, but my experiment, I didn't do 1.5. I only did 1, 2, 3, 4, 5. Then how to get? So you interpolate. So when you interpolate, when you draw your best fit line, actually that's interpolation, because you draw already. Okay, I imagine it's straight lah. Okay, let's say whatever. Let's say we draw already. Okay. Then what happened was, from here you because you interpolate means you find the data, find the relationship. You try to like bring the data together to help you find out this value of 1.5. So to interpolate means now you are predicting the value inside your range of data. What lines? Teacher, what's the name of the line? Which line? I'm trying to, you mean this line I'm drawing, is it? Best fit line. You learned before? Best fit line? Oh, oh, is it? Sorry. Oops, sorry. You asked if you drawn lines before. Yes, I know you. Yeah, what a silly question. Of course, you've drawn lines before. Be something line. So you drawn best fit lines before? Yeah. Best fit lines. Yeah. So you know it as something, but not with this name. Best fit line in maths. Same. Okay. Okay, up to here first. Look, this is just basic stuff. You won't know how to apply this until the time comes. So when we do the experiments and you draw graphs, then I'll guide you on this. Once you do like about 1 or 2, after a while you get the hang of it already. Okay?